Hi, I'm Miss Hall, and this is Lesson 19, Complex Solutions and Zeros, Completing the Square. We'll begin with complex solutions. Prior to learning about imaginary numbers, when we ended up with solving a quadratic as x squared equals, say, -9, we wrote no real solution. But now that we have this imaginary unit I, we can simplify and get a complex solution. So for example, A, to solve x squared plus 4 equals 0, we're going to isolate the x squared so that x squared equals -4. Take the square root of both sides. And this is where earlier we would have said no real solution. You cannot take the square root of a negative number. Well, a real solution does not exist. That's why we wrote no real solution, but there is an imaginary solution or a complex solution. And it is x is plus or minus the square root of -4. And we can write the square root of -4 as the square root of -1 times the square root of 4. The square root of -1 is I. Square root of 4 is 2. We still have this plus or minus. And now we're going to rewrite it as x equals plus or minus 2i. There's no real solution. There are complex solutions. B, same thing. We're going to isolate that x squared. We'll add 11 to both sides and get 2x squared equals -36. Divide both sides by 2. X squared equals -18. Take the square root of both sides. X equals plus or minus the square root of -18. We can simplify the square root of -18 as the square root of 1 times the square root of 9 times the square root of 2. We still have this plus or minus. This is I, 3, radical 2, plus or minus. I'll rewrite this as x equals plus or minus 3i radical 2. There's one more thing I want to add. When we solve a quadratic, remember I said that you're solving, you're finding the roots, you're finding the x-intercepts. If these have no real solutions, the parabolas never cross the x-axis. So for example, in A, the parabola we know is a vertical shift up 4 units. So there are no real x-intercepts. That's why there's no real solutions. B is again a parabola that faces up, that's the vertex is above the x-axis. So there are no real solutions. There are only complex solutions. On to completing the square. So we're going to be solving quadratic equations using square roots. Previously, you solved equations of the form u squared equals d by taking the square root of each side. This method also works when one side of the equation is a perfect square trinomial and the other side is a constant. Example 1, we're going to be solving using square roots. So solve. What works out here is that the left side is a perfect square trinomial. We can rewrite this as a binomial squared, and that is x minus 8 squared equals 100. And now we can take the square root of both sides, plus or minus, get x minus 8 equals plus or minus 10. X equals 8 plus or minus 10. So x equals, what's 8 plus 10 is 18. And x equals 8 minus 10, which is -2. So I can write that those are the two solutions. It's just important to note here that we can only use this method when one side is a perfect square trinomial, or we make one side a perfect square trinomial. In example 1, the expression x squared minus 16x plus 64 is a perfect square trinomial because it equals x minus 8 squared. Sometimes you need to add a term to an expression x squared plus bx to make it a perfect square of trinomial. This process is called completing the square. Here is the steps to completing the square. To complete the square for expression x squared plus bx, we will add b over 2 squared to both sides. Easier with an example, so if our expression was b plus 10x, x squared plus 10x, we wanted to complete the square, we would take this b value, which is 10, and do 10 divided by 2 squared. That is 5 squared. We would add 25 to x squared plus 10x to complete the square. Okay. So you can do this in words. You can do this in a diagram. If you in the diagram, the combined area of the shaded region is x squared plus bx. Adding b over 2 squared completes the square in the second diagram. So again, if we have x squared plus 10x, and we're looking for that third term that makes it a perfect square trinomial, you can picture this diagram where we have x squared, which is the product of x and x. We split 10 in half and get 5x, 5x. So the outside is 5, and then we multiply 5 by 5, and we get 25. To make this a square, we add 25 to both sides. Algebraically, what we are doing is we are taking half the b and squaring it. Half the b goes in our binomial. That is then squared, right? Half the b is 5, so this is really x plus 5 squared. And you can see it in the diagram that x plus 5 is the dimensions of the diagram. Example 3. We're going to solve this equation by completing the square. Our first step will be to get one side to look like x squared plus bx. So we're going to move that constant of 7 to the other side, and we're going to have x squared minus 10x equals negative 7. Now we are going to add the b over 2 squared value to both sides. That is half of negative 10, which is negative 5 squared. So that's plus 25. X squared minus 10x plus 25 equals negative 7 plus 25. In order to keep the equation still balanced, what we do to one side, we must do to the other. If the diagram was helpful for you, what we have here is we have x squared. We broke up negative 10x into negative 5x and negative 5x. So we have negative 5, and the product of negative 5 times negative 5 is just 25. Now the third step, we're going to factor and solve. We have a perfect square trinomial, so we can rewrite the left side as x minus 5 squared equals negative 7 plus 25 is 18. Now we're of the form u squared equals, what do they call it? Equals d, and we can take the square root of both sides, plus or minus. We have x minus 5 equals plus or minus the square root of 18. Let me do over here, the square root of 18 can be rewritten as the square root of 9 times the square root of 2, which is 3 square root of 2. And if I add both sides to if I add 5 to both sides, I'll get that x equals 5 plus or minus 3 radical 2. Going through my steps, I'm first going to isolate x squared plus bx. I'll move that constant term 5 to the other side. So I have x squared minus 18x equals negative 5. I will add b over 2 squared to both sides. b is negative 18. Half of negative 18 is negative 9. Negative 9 squared is positive 81. X squared minus 18x plus 81 equals negative 5 plus 81. Now I will factor and solve. X minus 9 squared equals 76. Take the square root of both sides, plus or minus. Get x minus 9 equals plus or minus radical 76. Radical 76, I'm going to simplify, is the same as radical 4 times radical 19, which is 2 radical 19. Okay. And so now I have x is equal to, add 9 plus or minus 2 radical 19. That's my answer.